access, right?
I'm sorry, when the traffic is destined for?
When the traffic is destined towards the firewall, okay, we will have the local policies.
Yes.
Right. So in that, right, from any source towards the firewall, the all services are opened, right? And obviously that is a, security concern, right? So, are we giving any explicit, in this particular...
Just wait there.
Okay.
Why do you think that it's a security concern?
Because why we need to, for any source, right? For any source, why we need to allow the access, in a given port. Let's say on the port 1, it is reachable, let's say.
Are you seeing my screen?
Yeah.
Okay. So which ports are allowed? 80, 443 and all those, right?
Right.
Anything is dropped. If there is any other ports, which is not a predefined one.
Okay.
These are the predefined, right?
Mm-hmm.
Maybe using it for any number of the reasons. Okay. So if that is the case, if you see in here, all those policies, the local on policies is defined for the predefined ports. Yes or no?
Right.
And but what is the default action? Any
yeah, drop.
Right?
Right.
Correct. Now see here for IGMP, OSPF, PIM, RIP, this is all. That is accept. That is your...
Oh, okay. We have a separate section where local in policies, we can see all this.
Yes. That is the local policy that you are talking about.
Right.
Okay. So here, so I didn't get that point. It's like when you say it's a security risk, I want to understand.
Okay. So what I mean to say, by default, okay, if you take the, firewall traffic, first is the pass-through traffic, right? The next one is, source, traffic will be initiated by some other device, okay, and destined towards the firewall, right? That can be accessed by any source.
Yes.
Right. So why we want to give, a specific source, that can be changed later, or how it will be?
Okay. So see, if you want that only a specific sources should be able to take access of my firewall.
Correct.
For example, if you want that. Okay. I think we have discussed this or not. Just correct me. I think I have showed you this. Maybe in this batch or the other, I'm not sure, but I think I have. See here. When you create an administrator, okay, here you can restrict the login to trusted host.
Okay.
So if I mention that, hey, this firewall can only be accessed from this IP. That means now no one other than this system can take the access of the server.
Okay. Got it. Only this particular 1.10 will can able to access this.
Yes, correct. Or you can give an entire subnet. That is also fine. Okay.
Understand. Okay.
So you can define who can take the access.
Okay. So here only the IP address or the subnetwork we can give, but not the addresses, right? Address or address set.
Address set.
Yeah, address or we cannot define here the address, right? Only the networks we have to call the IP addresses.
So what do you mean by address?
Address in the sense for any let's say in a given policy we will call the address object maybe. Yeah.
Okay,
object host.
Here you have to give the IP. After all, address object is nothing but the same thing, right?
Right.
So what's the difference then?
No. Address and object both are same only because Juniper, we just call it as address. Okay. So maybe in Palo Alto or here maybe object which will be called.
So whatever you call it, it's like that is the same thing, right? After all, you have to give an IP, right?
Right. So what I'm thinking is, so let's say if already existing objects are there, let's say, okay. So in this okay, we cannot call objects.
You
right?
have to add the IP.
Oh, okay, that's right. Yeah, my question is that. Okay.
Rohan, how frequently we use that options, restrict login to the trusted host?
That depends. If you are really working in a very controlled and secure environment, like for example, Navy SEALs, military kind of an setup, DMZ zones, okay, there it is a very, very highly restricted environment.
Right.
Okay? So you may be working on this.
Okay.
I see. Thank you.
Okay. And if you configure here this, this particular, trusted host one, then this particular IP, let's say, if from any of the firewall interface, if that traffic comes, we can able to access, right?
This is what, see here, what
device level entire.
Here you are what defining is that my user admin.
Mm-hmm.
So if someone is saying that he has a, see now what happens now that anyone can send a request, okay? He will get a login prompt.
Okay.
He will get that login prompt, that enter username and password. But when he will enter admin as a username, okay, then he will fail if in case the system what he is using to access that system do not has this IP.
Right.
Then this login will not work. Although he may have the right to use username and password. Okay.
Right. Yeah, but he's right.
So he has to be on this system. Then only this username and password will work.
Understand. Okay. So on the same, this one. Okay. So one more query is, let's say here we have in the local policies or in the administrators, we have configured it as source any and destined to the firewall, right? By default, it will be there. Okay, but what if?
Can you please come again? Source.
Okay, source any from any source. Okay, let's say we don't have this restriction.
Okay, you don't have this.
Oh, let's say we will take the default scenario.
Okay.
Okay. Then source. Now, if you don't restrict anything, source can be any. Destination is your firewall management IP.
Yes.
Right.
Yes.
Okay. So now I have configured a policy, DNAT policy in the where is that security policy? Can you go to the security policy?
Security policy or firewall?
Maybe okay, firewall policy, right? Okay. So here I have configured a policy stating that source is specific IP. Okay, and destined or source is any destined to firewall. I have denied a policy here.
That is something which you cannot create. That is hypothetical.
I mean, I just
no. See.
Okay.
Why I said that you can only create a firewall policy for the pass-through. Why I said that? Because
right.
Create a policy. You have to define incoming and outgoing, right?
Right, exactly.
And what is incoming in that case? Port 1. Outgoing will also be port 1, right? That can happen. Yes or no?
Right.
That can happen, right? But the traffic what you are sending is not from LAN to LAN.
Right, exactly.
You are actually sending to the firewall. That is management traffic. That can only be controlled by local in policy. You cannot control it by the firewall policy.
Understand. I missed the logic that one. Right. Understand. Okay, yeah. I got my answers. Okay. Thank you.
Okay. So let me share my screen. We will start this topic. Where is my whiteboard? Okay. Okay, so today we will start with a DNAT. Okay. So see, in FortiGate firewall, I think I have started the recording now. Yeah, okay. So in FortiGate firewall, DNAT is also referred as VIP. Okay. Where the V stands for virtual IP. Okay. So you call it a DNAT, you call it VIP. It's the same thing. Do not get confused. Okay. So it's the same thing. Just the words are different. So in FortiGate terminology, the DNAT is referred as VIP. Okay, clear? Now, see, the question first is, when I will need a DNAT, how would I know that I have to implement a DNAT? What is the challenge? Okay, so first of all, let us understand the challenge. Then only we will come to a solution. Okay, so the setup is in this way. Let's say I have a server. Okay, and the server is connected to the FortiGate firewall. I will keep it simple. FortiGate firewall. This FortiGate is connected to internet and someone is working from home. Okay, just give me a moment. Let me have some. Okay, so yeah. So let's say I'm working from home. Okay, so this server, actually what it is posted inside the firewall is on the IP 192.168.1.10. This is the server IP. Clear? Now, that means this interface, let's assume it is port 1. So the IP of this port 1 is 192.168.1.1, for an example. Clear? This is my port 2. And the IP of this port 2 is 1.2.3.4. Clear? Now, for an example, I am onto this PC and my public IP is, which I'm working from home, okay? So my like broadband IP. So that is 11.12.13.14. Now, I want to access this server. This is nothing but a web server, okay? This is a web server which is hosted on port 443. For an example, okay? If I have to access this server, what I will do? I will say, hey, HTTPS 192.168.1.10. Correct? Yes or no?
Yes.
So when the PC will try to send this, how the packet will look like? The packet will be looking like this. Source is 11.12.13.14. Maybe with a random port. Random port would be, let's say, 5543. And destination will be 192.168.1.10. Destination port will be 443. Yes or no?
Yes.
So now when the PC will try to send this packet, will this packet go? Will this packet go to the internet?
No.
No distance. No.
No. Why?
No, because there's a no path.
No netting.
Ask. Why this packet will not be sent on to the internet?
We have to configure something in a Fortinet, right? So that it can...
Because the private IP is not routable.
Correct. Forget about Fortinet. This packet is created on the PC side, right? Destination is what? Private IP.
Right.
Can your internet help to reach this IP, which is a private IP? No.
No.
Okay. So your packet cannot go to the internet. So your packet is dropped. You will never ever get the access of the server. Yes or no?
Yes.
So what is the solution? The solution to that is, there are two solutions, okay? First is build up a VPN. Of course, you build up a VPN and you can achieve this with a private IP range. You can do that, okay? So I'm not going much into a VPN. That is something which we'll see when we will start discussing the VPN, okay? But yes, to achieve this, I can achieve this using a VPN. But okay, do you think that if I have to access Google, just think, if that web server is none other than Google, now do I have to establish a VPN to access Google? No, right?
No.
It's a website, okay? So I want that. So what is the solution? So VPN is not always the solution, okay? So what is the second one? What is the common? Let's say I really have to access a Google page or some related to a website. What is the solution? The solution is I cannot work with a private IP range. I need to have a public IP. Yes or no?
Yes.
Yes.
So since your server is hosted behind the FortiGate firewall and your FortiGate firewall public IP is 1.2.3.4, hence, instead of this, your PC should actually sending the traffic to
1.2.3.4. Yes.
So no, right?
Yes.
Now, since now if I try to access this website, this URL, now how will the packet look like? The packet will look like this. That the source is 11.12.13.14 with the source port 5543. Destination is 1.2.3.4 with the destination port 443, correct?
Yes.
Now, the PC can send this packet over the ISP.
Yeah.
Now the ISP will say, hey, the destination is 1.2.3.4. It will do a routing lookup onto its own site, whatever he does, okay? So based upon that, now the ISP will send that packet towards the FortiGate firewall.
Yeah.
Okay? So FortiGate firewall receives this packet.
Yes.
So when the FortiGate firewall receives this packet, what the FortiGate firewall is saying, okay, fine. The request is coming from source 11.12.13.14 who has the source port 5543. The destination is 1.2.3.4, 443. Correct? Correct?
Yes.
Now, if this packet has to reach to the server, that means the FortiGate has to translate the destination IP. Yes or no?
Yep. Yep.
He has to translate the destination IP to 192.168.1.10.
Yes.
And that once it has done the destination translation, then he will do the routing lookup for this. And as per the routing lookup for the destination NATed IP, he will know, okay, I have to send the packet out via port 1. Correct?
Yes.
Yes.
Right? And finally, when the server receives the packet, what it will see that I have received the packet from source 11.12.13.14 with the source port 5543 and destination is 192.168.1.10 with the port 443. Now the server can see, okay, what is the destination? 1.10. So server will say, hey, it's me, right? That's when the server will then generate a reply packet, correct?
Yes.
So in short, if this PC wants to reach to this server or you want to ensure that this web server is accessible from the outside network, that means you have to configure DNAT onto the FortiGate firewall because FortiGate firewall has to translate the destination. Clear?
Yes.
That's the use case of DNAT. If someone who is coming from outside who wants to access something which is internal and you need to translate the destination IP, that is where you have to configure a DNAT. Clear?
Yes. Rohan,
Yes, please.
so do you think, I'm sorry if it is a dumb question. So
No, not
do
a
you think
question.
yeah, do you think this is kind of risky the way it is going? Because we just directly go to the firewall with the netting.
Where you find it risky?
Like for example, from the outside source, right? From the outside PC, you can, if you have the netting in firewall, you can directly go, right? You can
So
directly
that means-
hit the firewall.
So directly hit the firewall.
No, via ISP is gonna hit the firewall, right?
ISP will
I mean-
not hide the firewall. That's
So
public IP assigned to the firewall, right?
yes. Yeah, I know. But for example, my my home network is 192.168, right? Hold on. My home network is 11 dot something, which is public IPs.
Yeah, 11.12.13.14.
Yeah, that's directly actually hitting the
Firewall.
firewall.
Yes, because see, if you look with reference to the PC, the PC is thinking that he is talking to the server on the IP 1.2.3.4, right?
Yeah.
But what is your server IP actually? That is 192 series, right?
Yeah.
So the role of the firewall is to safeguard your resource.
I see.
No one can compromise your server because the identity of the server is hidden. Everyone is thinking, like for example, when we try to access Google, right? So are we really seeing the Google IP on, it's like the server IP where the Google is hosted? No. We are simply seeing the mask IP, that is the NAT IP, right?
Right.
Yes.
That is what the whole point is.
Okay. Okay. Do you think those kind of scenario we should isolate the whole zone to the new, like for example, not an inside zone, put it in a different zone, like in case of, so if something is compromised?
Nothing will be compromised, and even if you put it in a zone or like without zone, is especially I'm making this statement in terms of FortiGate firewall. Okay.
Okay.
Even you deploy this kind of setup either with reference to different zones or in same zones or without zones, that doesn't matter.
Okay.
The firewall, for the FortiGate firewall, like I have told you earlier as well, it do not anything as a special preference. Okay, there is nothing as in that case. How it will be port 2 to port 1, it will do the same kind of behavior for zone or intra-zone or for inter-zone.
I see. Thank you, Ron.
Okay, Rohan, I have a question.
Yes, please.
Okay, so when the user on this piece is trying to access the server, like the web server, and when the web server is replying back to that the end user, what will be the source IP address for the reply packet? It should be the one which is on port 2 or firewall, which is the native IP address, or actual IP address of the server.
Now see, for the server has got what IP? Server,
so 192.
got this packet, right?
Yep.
From the firewall, server is getting this packet, correct? So when the server will try to reply, okay, when the server will try to reply, he will say the reply packet source is 192.168.1.10.
Yes.
Yes.
443 as in source port. Destination will be 11.12.13.14.
Yes.
5543, correct?
Yep.
Now your server should know how to reach, like how to send the packet out of if the destination is this, right? So server will do a routing lookup, and as per its routing cache, it knows that, okay, fine, I have to send it to the gateway of the firewall. That is this one, correct?
Yes.
This is the packet that is sent on to the FortiGate firewall. FortiGate?
Yes.
Now, since FortiGate has maintained a netting table, When it
Okay.
it does a NAT, it maintains. So it knows that, okay, I have done a DNAT for what? He will say, I translated
2.3.4 against
443 against
192.168.1.10.
443, correct?
443. Yeah.
So when this reply packet is coming here, he will do a reverse NAT.
Okay.
So he will translate this IP.
Yeah. The source IP will be 1.2.3.4 for the end user.
So now in that case, the source will change to 1.2.3.4, 443, and destination will remain as
11.20, 12.13, 14.
And
5443.
Now this reply packet has been sent to your PC.
Okay, got it.
Since your PC has sent this packet, so of course he will accept this reply, right?
Yes.
Right, because the PC sent the packet to this destination and he is getting a reply from the same, right? So he will accept it, correct?
Yep.
So it's the same thing, same app approach, okay?
Okay, yeah, I got it.
Okay.
Rohan, is there any big difference in between SNAT and DNAT? They sound like similar.
The big difference is SNAT translates the source IP and source port. DNAT translates the destination IP and destination port.
Ah, thank you.
The name is itself different, man. Source NAT and DNAT, that means just...
Yeah. Gotcha. Thanks.
Okay.
So Rohan, in this scenario, we required a dedicated IP for web server.
We have got a dedicated IP, it's like as in public IP.
Yeah.
See, when you host a web server, you do not host it on an IP, right? You actually create a FQDN, right? For example, google.com, right?
Okay.
So actually in your PC, you are running this, na? Google.com.
Right.
But what your PC is doing, it is resolving domain to some IP.
Yeah. Public
Right?
IP.
Yes, it is resolving to that public IP, because after all, it's all the IP based communications, right?
But we need a dedicated public IP for this URL.
You have to.
If we hosted like 10 websites, so in that case we also required 10 different
No, you can host all those 10 servers on a same public IP. You can do that.
with different port number, right?
Yes, correct.
It is something like we are doing the dynamic netting in Cisco kind of things.
Yes.
So like same IP address and we are changing the port on the destination.
Yeah,
ports.
The ports will keep on changing. The rest of the IP will remain same.
Okay.
Okay.
Okay, thank you.
Okay. Now, so clear with this example?
Yes.
Now, see here, one thing. In this, we actually translated what? Only the IP, right? I only translated the IP. I didn't translated the port, did I?
No.
Did I translated the port? No, I only translated the IP. Okay. Now, what is the scenario or what is the challenge where I need to translate the port? Right? Now, see, I'm taking the same example, okay? I will take the same example. Let me draw the figure. You have a PC. I will take the same IP on port 2. Let's say the IP is 1.2.3.4. Here my PC public IP is 11.12.13.14. This is my port 1, whose IP is 192.168.1.1. Okay. And my server IP is 192.168.1.10. Okay. It is a web-based server hosted on 443. And for an example, I will say, yeah, okay, let it be, okay, or hosted on 443, okay. Now, on this PC, okay, my first thing is, I will take one more PC, okay, just for the sake of argument. PC1 and PC2. Now, this PC1 has also a public IP, okay, and that public IP is 33.44. Well, let me keep it simple, okay. 11.22.33.44. Okay, this is the public IP of this PC. Now, the point is, for an example, this PC2 wanted to access the web server. So he executed HTTPS, and of course you have configured a DNAT over here. Okay, where you have told in a DNAT configuration, you have told that, hey, translate the destination, okay, translate the destination of 1.2.3.4. So you are saying if any packet has the destination 1234, translate it to 192.168.1.10. Clear? That is the destination NAT entry that is in the firewall. Okay, clear? Now, see it. Now, if this PC is trying to reach, okay, so I want to reach to the web server here from this PC. Okay, that is what I want to do. So I am accessing this 1.2.3.4. Clear? Clear?
Yes.
Yeah.
So when this PC2 will send the packet, how that packet will look like? The source is 11.12.13.14. Destination is 1.2.3.4. Let's say source port is 5543 and destination is 443. Clear?
Yes.
When this packet is reaching to the ISP and the ISP is sending it to the fortigate. Now fortigate will translate this destination based upon the DNAT entry.
Yes.
And the destination will be translated to whom? 192.168.1.10?
Yes.
Yes.
And hence the packet will be sent further to the server. Correct?
Yep.
So you have got the web server access. Clear?
Yes.
Yes.
Now, it's the same thing which we discussed just yesterday, like the previous slide, okay? The same thing. Now, next, from the PC1, I want to, okay, take the access of firewall. Okay, I want to take the access of the fortigate firewall. Hence, I am also sending a request. The PC1 is also sending a request to 1.2.3.4. That is the firewall public IP. Yes or no?
Yes.
So I want firewall access, firewall GUI access. Okay, from the PC1. Now, the PC1 will form a packet. That packet will look like this. Source is 11.22.33.44. Source port may be 6643 for example. Destination will be 1.2.3.4. Destination port is 443 because you want to take the firewall access. Clear?
Yes.
Yes.
Now, when this packet will be sent from the PC towards the ISP will send it to the fortigate firewall.
Yes.
Yes.
Fortigate firewall has a DNAT entry. You all know about life of packet. First, integrity check, then TAPI portal, then DNAT, right?
Yeah.
Yes.
First, it will translate the destination. So it translated the destination of 12342 to 192.168.1.10, correct?
Yes.
And then it will do a routing lookup for the destination. So when it will do the routing lookup for destination 1.10, it will say the packet has to be sent out to the server, correct?
Yes.
So the PC1 will end up getting web server access, correct?
Yes.
But what he wanted?
Firewall access.
Firewall access, right? So the point is, if I configure the DNAT, That means, does it mean that I cannot access the firewall through my public IP? No. Here, you have to be slightly careful. What you can do here is, okay, you can say that, hey, now there are two ways, okay? Either you can host your firewall on not on a 443, rather on a different port, that is 4433, right? Right?
Yep.
So even if you host your firewall on 4433 port, challenge is this is translating the IPs, correct?
Yes.
Irrespective of the destination port, your DNAT configuration is saying that, hey, if any packet comes with the destination of 1.2.3.4, that destination IP should be translated to 192.168.1.10, correct? Correct.
Yep.
Yeah.
So no matter which destination port you choose, the IP will change, right? This is why in DNAT, you have to enable port forwarding. There is now I'm using a new term, that is port forwarding. Okay. Now do not get carried away that, hey, is this something new now? It's a big configuration. No, not at all. Port forwarding is nothing but PAT in terms of destination port. Okay. So when you translate a destination port, that is called port forwarding, or you can say PAT action for the destination port. Clear? Clear?
Yes.
So here what you are saying, here instead that I define the IPs only, I will say that, hey, look, if the request is coming for 1.2.3.4 and the destination port is 443, then translate the IP to 192.168.1.10 to 443. Clear?
Yes.
So that means that if this PC1 is sending a request for destination port 4433 as a destination, now the DNAT will never match. Okay, because the destination is what? 1.2.3.4 and destination port is 4433. It is not a match, correct?
Yes.
So hence this will only, now the firewall will say, okay, hey, so I do not have to translate this IP, right? So that means who is this destination? 1, 2, 3, 4. Firewall will say it's me, right? And okay, and he wants to access what? 4433. So as per your configuration, if you have done the GUI access on 4433, hence the firewall will send you a response and you will get a access of the firewall. Clear?
Yes.
Or instead of that, what you can do is, which mostly the people does, okay, I will not delete all the things, okay, let it be. Okay, so instead of this, instead that you change this, okay, what you will do is, you will configure saying that, hey, this web server is accessible on 4433. Okay, that is what mostly people does. Why? Because they will try to hide not only the IP, but also the actual service port on which the server is working. Okay. Okay.
Yep.
They may also be trying to do that. So they will say, hey, if you want to reach to a server, now you have to send the traffic onto this destination port, 4433. So what you will do is, you instead of here, you will create an entry 4433. Send it to 443. Okay. So now what will happen is, if the destination is IP 1.2.3.4 and destination port is 4433, modify it to 192.168.1.10 and destination port is also modified. Clear? Clear?
Yes.
So you are not only hiding the IP, but you are also hiding the service port. Clear? So whenever you translate the destination port, that is called DPAT. That is destination path, port address translation. Okay. Or in short, we will call it as port forwarding. Okay. Now let me show you the configuration. Okay, let me show you the configuration.
Rohan,
Lab as well. Yeah. Tell me.
If port remains same, in that case, what happens?
If port remains same, then it will be a conflict. I told you, na. See.
So one service may be dropped, right?
One service. No.
Either.
Everyone will be getting this web server access. No one will get the firewall access, na.
Okay.
Because every packet will be forwarded to the server.
Okay. That's why we need to change the port, right?
If you want that, I should be able to take the access of the firewall as well as the server should also be accessible at the same time. Okay, using the same public IP, you have to play with port. Okay. Now,
yeah, I have one question.
you have one doubt?
Yeah.
Yeah, tell me.
Yeah, you told this firewall PC1 is now how the PC1 is accessing the firewall with the port, different port. I didn't get that point.
Okay. So this one where I was saying 4433.
Yes. This destination is a dynamic learned IPS, and the.
I think I'm losing your audio.
Hello.
Yes. Tell me.
Yeah. What I'm asking is this destination is dynamically learned. Yes. Am I right?
Dynamically learned.
Yeah. From the DHCP. Yes. From ISP.
Which one? This IP?
No. Yeah. Destination here. Destination 1.2.3.4 on 4.4. Yes.
So you are entering that manually on the PC, na?
Yeah. We configured dynamic IP configuration. Yes.
Where you are talking
in
about?
The PC.
I think he's talking about the P2 IP address, which is public IPs 1.2.3.4.
Yes. Yeah.
You're talking about this?
Yes. No. PC1 IP. PC1. Whatever it is. Either
22.33.44.
No. He's talking about PC1 destination IP, which is 1.2.3.4.
Yeah. Okay.
Yeah. This destination IP is from ISP. Yes. Auto configuration.
No.
We then how we will get the information about the destination IP?
Hey, you are the. Oh, come on. See here. Do you know about DNS?
Yes, I mean the domain name system. Yes.
So when you access google.com, this is the IP, na?
Okay, fine.
So how does your PC know that what IP it has to send the packet to when you try to access Google? Because it is doing a domain name resolution, correct?
Okay. Okay. It is resolving the name to the corresponding IP. Yes.
Okay. So now if you are saying that, how would the PC know that how it has to reach to the firewall?
Yeah.
Now that is something which is like you are the network administrator, right? That's why you are accessing the firewall in the first place. So you know what is the public IP of the firewall that you want to take the access to, correct?
Yes, right. No, so, but how the port we will allocate. For example, you are telling that this 1.2.3.4 on 2 different ports for accessing the firewall and web server. Yes.
Okay, fine. Forget about all this. Okay. Again, I'm again repeating the entire process. Okay. See here. See. Server. First, try to understand the challenge. Okay. What was the challenge? Yeah. I think you lost in there itself. Please have just like, let me know if you're not getting the first challenge. Okay.
Okay.
This is a web server. Okay. Which is hosted on port 443. For an example, by default. Okay. Now, this is connected to the firewall. Clear?
Yes, clear.
Your public IP is 1.2.3.4. Okay.
Yeah, okay.
Your server IP is 192.168.1.10, which is hosted on port 443. Clear?
Yes,
Now,
clear.
internet. Clear?
Yes, clear.
So how does the firewall got 1, 2, 3, 4 IP? Do you have a doubt onto that? It is manually, or it is triple PO link, or it is DSCP, whatever the reason is. That is not my concern. The firewall has 1, 2, 3, 4 IP as in public IP. Fine.
Okay.
Clear up to this?
Yes, this 1.2.3.4, is it from the, as you say, is it from any of the way, or is it from NATing? This public IP.
Okay.
As for ISP, the ISP giving that IP so that you can configure the firewall as an outside interface.
Yeah. Yesterday, as we explained, it is looking the port, yes, interface. Okay.
It's a simple IP assignment to an interface. Nothing more.
Yeah.
Okay. There is no NAT and nothing at all. Simple.
Yes.
Like, how would I put it? You are simply opening a device and assigning an IP to an interface.
Yeah. Okay.
Clear?
Yes.
Okay. Fine. Now see, in the PC, in the ISP, you have one PC here, and there is one more PC. Clear?
Yes,
now,
clear.
This is PC1, this is PC2. So maybe you're working on a broadband or on your hotspot, whatever the reason is, okay, whatever the network is. So you will get a public IP of your own.
Okay.
Any doubts onto that, or it's like you are really confident that your PC will
Yes, confident. It is from the ISP. Okay.
Okay, fine. So your public IP has gotten, so your PC1 has gotten public IP. That IP is 11.12.13.14. Okay. Similarly, your PC is like someone who is working from some different place. He has also got a public IP of his home network. Okay. And that is 11.22.33.44. Clear up to this?
Yes, clear.
No questions in your mind that how they have got the IPs and all?
No.
Okay, fine. Now, see here. First thing, this PC1, okay, from PC1, I want to reach server. Clear?
Yeah.
Okay, so what I will do, I will access in this manner, HTTPS 1.2.3.4.
Okay.
Fine?
Yes.
Okay, now that means when the PC1 will send a packet, it will say the source is 11.12.13.14.
Okay.
Destination is
1.2.3.4.
1.2.3.4. Destination port is 443. And let's assume source port is 5543. Clear?
Yeah.
Okay. Now, this packet will reach to the internet. Clear?
Yes, okay.
Okay. Now, this packet which reaches to the internet will now reach to the FortiGate firewall.
Yeah.
Okay. Now, when this, okay, let me draw it in a different color altogether so that you will have a clear picture. Okay. See here. ISP towards the FortiGate firewall. Now, on the FortiGate firewall, okay, on the FortiGate firewall, you have configured a DNAT saying that, hey, if the destination is 1.2.3.4, translate this IP to 192.168.1.10. Correct?
Yeah, all right.
Why you have done that? Because
for reaching the server, yeah.
To reach to the server, right? Now, so when this packet is received onto the FortiGate firewall, the FortiGate firewall will translate the destination IP.
Yes.
So when it will do the translation, it will translate it to 192.168.1.10.
Okay, fine.
And hence it will forward the packet to server.
Yeah, great.
Clear up to this point?
Yes, clear.
Okay, now my other requirement that from PC2, I want to take access of FortiGate, GUI access of FortiGate. Okay, I want to take GUI access. Clear?
Yes, clear.
Now, when this PC2 is sending the traffic, okay, or it's like, how will I take? I will write HTTPS 1.2.3.4.
Okay.
If I have to take the access of the firewall, of course, I will try to access the firewall public IP. Yes or no?
Public IP, yes.
So I'm writing this. PC2 is writing this. HTTPS:/1234. So how does a packet look like? The packet will look like this. That the source is
11.22.
11.22.33.44. Let's say source port is 6643.
Yeah, right.
Destination will be 1.2.3.4. Destination port is 443.
Okay.
Clear?
Yes, clear.
Now this packet will be sent to ISP.
Okay.
The PC2 will send the packet now to
Yeah.
the ISP. Now ISP will send it to the firewall.
Yes, got it.
So firewall will modify the destination based upon the DNAT entry.
Yeah, agreed.
So when it will modify the destination will be modified to 192.168.1.10.
Yes.
And as per routing lookup, 1.10 is behind this. Let's assume this is port 1. Correct?
Yes.
So your packet finally reaches to the server.
Yes, okay.
So did your PC2 got the access of the firewall? No. I think he still have it out.
No, yeah, it already reaches the server, yes.
It reached to the server, right?
Yes.
So did your PC2 got the access of the firewall?
No.
No, because this IP is translated, yes.
Yes, because
Okay.
the packet, because the firewall is not responding. Actually, it is forwarding that packet to the server. So, so where he wanted the firewall access, he actually got the web server access.
Yes.
Yeah.
Yes or no?
Yes.
Yes.
That is what I was saying. This is the challenge. So did you understand the challenge?
Yeah, I got the point.
Okay. Now the question was that, hey, I want both. That if someone wants to reach to the web server, he can reach to the web server. And if someone wants to access the firewall, he can also get the access of the firewall. And I want both the functions to be performed on the IP 1.2.3.4. Clear?
Okay.
So how will I achieve that? To answer that, the solution is port forwarding. That means patting. You have to translate the destination port. Clear?
Yes.
So instead that you host the FortiGate firewall on 443, you can host the FortiGate firewall on some different port. Or you can host the web server. Instead of 443, you host the web server on 4433. You can also do that. But any one of that has to be hosted on a different port.
Yes.
Yes.
Right?
Yes.
Now, what you want to host? You want to host FortiGate or you want to host server? Tell me.
Yeah, FortiGate.
Okay, fine. So let us remove this. So now you want to host FortiGate on a different port. Now you said that, hey, if you have to access the FortiGate firewall, you have to come to the port. Let's say FortiGate firewall is accessible on the port 4444. Okay?
Okay.
Okay, now what you do is, now this person who wanted to access the FortiGate firewall, he then did what? he, instead of running the URL directly, he mentioned 4444 that, hey, I want to access 1234 IP that is on 4444, right? That is how you will write.
Yes, right.
Okay, so your packet will look like this then.
Yes.
Source is 11.22.33.44. Source port 6643. Destination is 1.2.3.4 and destination port is 4444. Correct?
Yeah, right.
Now, when this packet is sent to the ISP, ISP is sending it to the FortiGate firewall. FortiGate firewall will see the destination NAT entry. Destination NAT entry saying what? That if the destination is 1.2.3.4,
It's changing to I192.168.1.10.
change it to 192.168.1.10. Now, again, this IP is being translated.
Yeah.
And hence the packet will again reach to server.
Yes.
So even though you ended up changing the port, destination port, still you are not getting the access of the firewall.
Yeah.
Right.
Yes.
Right?
Right.
So
Yeah.
that's why changing the port is not enough. When you are in such a situation, you also have to enable port forwarding. So when you enable port forwarding, what you say is that, hey, 1.2.3.4, if this IP is in destination and the destination port is 443, then only translate this to 192.168.1.10 and destination port will also be 443 because you have not modified the IP, the port here, right? So that's why I'm not changing the ports.
Yes.
Okay. Now
Yes.
what will happen is, now if someone is trying to access the firewall using this, now if this packet reaches to the FortiGate firewall will say, hey, the destination IP is 1.2.3.4
But the
and
port is
destination port is 4444. Is it
Okay.
a match?
Yes.
It's not a match, right?
yes.
So the translation will not happen for this packet. Clear?
Yeah. Good. Yes.
Yes. Yes.
And this is when the FortiGate will now it will do the routing lookup, because see the life of packet. What was that? After DNAT, routing lookup is done, right?
Yeah.
So when it will do a routing lookup, what it will see? That, okay, destination is 1.2.3.4. Who has this IP? He himself.
Yes.
Hence, the response will now be provided by the FortiGate firewall. And in this way, the PC2 will end up getting the access of the firewall. Clear?
Yeah. Yes.
So
Is it clear now?
Yeah, thank you. Please validate my statements, what I understanding. I mean, we need to configure, if we are doing DNAT in the firewall, we need to configure additional NATing for the port translation. Am I right? Port forwarding.
In DNAT, if in case you are in such a situation, then yes, you have to do it.
Okay, okay.
Okay.
And another thing is, if DNAT stages fail, then it will look for the routing table for further action.
DNAT never fails. DNAT will not match. Then it will look for
okay.
routing thing. Okay.
Yes. Okay. Okay.
Yes. Okay.
And another right side, you told this our physical. This is physical port. Yes. Tetra 4. For example, this FGT 4444, and how you are mentioning in this URL 4444. How I know?
How you know?
Yes.
System settings. Remember, I told you that if you want to host, I also showed you that when I accessed with 8080, here you can 444. That my firewall will be accessible on the port 4444. Remember?
Yep.
Okay.
If you have missed that point, please refer my first day video.
Okay.
Okay. Clear?
Yeah. Thank you. And so what we are discussing now is dynamic NATing.
No, I'm not discussing a static or like dynamic. I am a very simple and average kind of a person. Okay. I don't go into those terms. I am discussing DNAT.
Okay.
Okay. Whether it is a static or whether it is dynamic, that doesn't matter. For me, it's a DNAT.
Yeah. I go through your yesterday's class that in the first the types overload 1 to many
That
like
is
that.
source NAT, brother. That is source
Source
NAT.
NAT. Yeah. So is it like many to many or like that?
No. In DNAT, you have nothing as such. DNAT is
Nothing
simple.
like that. Huh?
No. In source NAT only you have those 4 types. DNAT is DNAT. Okay, there is no types into it.
So okay, then is it that the NATing will support multicast networks?
It will support anything where it needs to translate the IP, whether that IP is a multicast, unicast, broadcast, that doesn't matter.
Okay.
Okay? It's simply an IP to IP translation.
Okay. Yeah. Thanks.
So let me show you the lab as well. That will give you.
We will see it's practical too, no?
Okay.
You will get much more insight. Okay, let me just do a quick lab. Okay.
Yeah. Thanks.
Here you have virtual IPs. Okay, like I mentioned, DNAT is referred as VIP, virtual IP in the FortiGate firewall. So if you have to configure a DNAT, you have to go in here. Now, my task is, okay, what I'm going to show you is I'm saying I will take the access of Fortinet 2 firewall with Fortinet 1 port 1 IP. Currently, port 1 IP of Fortinet 1 is what? 192.16.10.1, right? With reference to which I am taking the firewall 1 access. Clear?
Yes.
So I will use the same IP Yeah.
Can you please show me this access control list in GUI?
There is no such thing as an ACL defined in a GUI.